Okay, three things today. We have the first one, fundamental accounting principle. If you look in your notes, you see this first part, fundamental accounting principle. Fundamental accounting principle is when you're kind of doing a tree diagram, but instead of writing out the tree diagram, it's just easier to multiply. Okay, so if you have 3 pairs of pants and 2 shirts, you have 6 possible outfits. You just multiply 3 times 2. And how you've probably seen that before is that if I had 3 pairs of pants, right, pant 1, pant 2, pant 3, you would start a tree diagram like this. And then from each tree diagram, you would say, oh, shirt 1, shirt 2, and do that for each of them and count how many combinations you have. Well, that's kind of a lot of work to do a tree diagram all the time. So what you can do is just however many are in the first category times however many are in the second category times however many are in the third category, and you just keep going. And this works as long as you're picking one out of each category. Okay? So some examples. You want a 2-letter pair, 1 vowel and 1 consonant. So I'm picking 1 out of all the vowels, and then I'm picking 1 out of all the consonants. So the first thing we need to decide here is, okay, how many vowels are there? And we're not including Y. So how many vowels are there? A, E, I, O, U. So 5, right? So my first one, I'm picking 5 of the vowels, so 5, times, and then how many consonants are there then? If there's 5 vowels, 21, yep. So I would take 5 times 21, because there's 5 vowels, 5 consonants. I'm picking one of each, which is what? 105? So I'd say 105 ways, right? And you'd have to label that. 105 ways that I can pick 1 vowel and 1 consonant. That's because here's a letter and here's a letter. That makes a pair. Letter, consonant, vowel, consonant. It's a pair. So you'd say how many is in the first category, how many vowels are there, how many are in the second category, how many consonants there are, and then you multiply. Okay. Let's try another one. An ice cream shop offers 33 flavors of ice cream and 7 toppings. So you get to go in this ice cream shop, and you first of all get to pick a flavor, and then you get to pick a topping, right? 1 flavor, 1 topping. So you're picking 1 of each category. So how many flavors do I have? 33 times how many toppings do I have? 7, and you multiply 33 times 7, which would be how many? 231, we could say Sundays, right? Different Sundays. A lot of these are going to have labeled 231 different Sundays that you could pick by picking 1 flavor and 1 topping. Okay. One more. Contest winner gets to choose 1 of 8 possible vacations and bring 1 of her 10 friends with her. So again, you're making 2 choices and you're picking 1 out of each category. The first one you're picking is a vacation. So how many total vacations can you pick from? 8. So you put an 8 there. Times, and you only get to bring 1 friend with you. So out of your 10 friends, right, you're picking 1 again. So 8 times 10 would be 80, and you could say 80 prizes. 80 different ways you can select this. You pick a trip, you pick a friend. So each way you pick a different trip, different friend is a different combination. Okay? So that's the fundamental accounting principle. When you have categories and you have so many in each category and you're picking 1 out of each category. Okay? Another way you could do all of these, like I said, is tree diagram, but those really get big fast and take a lot of time. So it's easier to do fundamental accounting principle. The second one, permutation. And permutation, we practiced this last time on our last lesson, just using 10p4 on our calculators. Okay, most calculators have that. If you don't have a calculator at home and you need to do this homework, if you just Google Desmos Scientific Calculator, and I can even show that to you. Just online, Google Desmos Scientific Calculator, and you click on that. If you click this Func button, your NPR and NCR and factorial button are all right there. So if you ever get stuck somewhere, as long as you have internet in your iPad or your phone or something, you can. That's the easiest way I've found NPR, NCR. If you flip your phone on the side, those buttons aren't there. So you have to go to Desmos is a good one. There's probably a bunch of other ones. So NPR and CR permutations again, is when you want to have something arranged in a certain way. Okay, so is seating arrangement, where I put you in my classroom, order matters, right? How you sit at a table, if you're going to make wedding and you're going to seat people at your table, at certain tables, that'll all be a permutation. How many ways can you arrange your guests at tables? If you're hanging pictures on a wall, right, you just don't put the pictures up, you kind of arrange them so they look good with a certain, how many ways can I put those pictures in a certain order? Okay, permutation, order matters. So some examples, if you're ever talking about president, vice president, secretary, treasurer, order matters, right? It's a level of hierarchy. If you're talking about first, second, third place, that would be a permutation. Keyword would be arrange. If you ever see a problem that has the keywords arrange in them, that's, you know, it's a permutation. So let's look at some examples. An art gallery plans to display 7 sculptures in a single row. How many different arrangement of the sculptures are possible? So what you need to know to set this up is N is always the total number, and R is the number you're considering, or the number taken. Okay, N always has to be a bigger number or your calculator will tell you error, so you really can't do it wrong if your numbers are correct. So your total number, if I have 7 sculptures, and I want to pick, right, I want to pick all 7 of them to arrange in a certain row. So this would look like this, 7P7. How many ways can I take 7 of the sculptures and arrange them in a certain way? So in your calculator, 7P7, what do we get? Which would be 5,040 ways. Okay? If one sculpture is taken out of the show, so now I have 7 sculptures, and now I'm picking 6 of the 7 because one's coming out, right? So how many ways do I pick 6 of the 7 sculptures to arrange? So you should notice the number gets, what, bigger or smaller? It stays the same? Because that one taken out is the one that would be the combination in here. So 5,040 ways. Example, in how many ways of 4 distinct positions for a relay race can be assigned for a team of 9 runners. So I have 9 people that can sprint the 100 dash and we're running the 4x1. So how many ways can I pick 4 of those 9 to run the 4x1? So my N is what? 9. I have 9 total runners. I'm picking 4 of them, right? And I'm putting them in a certain order. If I was just going to pick 4 people and say, go run the open 200, permutation's not really, order doesn't really matter. It's just here you go run. But if I'm talking about a certain way I want to order these 4 runners, you start, you're second, you're third, you're fourth. That's why it's a permutation, which is how many? 8,000? 3,000. 3,000 what? Ways. Combinations pretty much the same thing. N stands for the total. R stands for the number taken. Combination order doesn't matter. So something like if I said Joe, Billy, and Bob, you guys need to go to the office. Does it matter that I said Joe's name first? No. Okay, so you're talking about a combination. If I was going to get, I get to pick 3 pieces of candy out of the bag, and I reach in and I grab Snickers, M&Ms, and another Snickers. Does it matter that I grab the Snickers first? No, because I get 3 pieces of candy and I'm happy. So sometimes when you're just grabbing things or just need a group of something and order doesn't matter, that'd be a combination. So 30 people apply for 10 job openings as welders. How many different groups of people can be hired? So again, it doesn't matter who you hire first, second, third, all 10 people are starting this job. So again, how many total people am I starting with? The total number, 30, and I'm choosing 10 of them to fill this position. Okay, and combination numbers will be smaller than permutations. What is it? Who's got it? 3, 0, 0, 4, 5, 0, 1, 5. So 30,045,015 ways. Okay. A paint store offers 15 different shades of blue. How many different ways could you purchase 3 shades of blue? You're going to pick 3 different colors of blue. Does it matter which one you bought first? Nope, you're just picking those 3 and you're going to paint with them. So I have 15 total paint. I'm choosing 3 of them to paint with. How many is that? 455 ways. Okay. So the hard part with your homework, as you see, your homework starts here, is that they're all mixed up. And you kind of need to decide, okay, is this fundamental accounting principle? Am I picking 1 out of each category? Am I picking 1 pair of pants and then 1 shirt and then 1 pair of shoes? Is this a permutation? Does it have the keywords like arrange? Or am I talking about certain positions, president, vice president, first, second, a certain way things have to be ordered? Or is it a combination where I just want a small group from the bigger group and order doesn't matter? So when you go through them, that's the first thing you have to do, just decide which one is it, and then you solve. First homework question is kind of tricky. You must make a password for your email account. The password must consist of 2 letters followed by 4 digits. So 2 letters, 4 digits, okay? So can I repeat letters? Yes, it doesn't say I can't, right? And it doesn't say there's a difference between capital and lowercase, so we're just gonna assume there's just 26 letters. If there was a difference between capital and lowercase, then I would have twice that many to choose from. So I'm going to have 26 letters here I can choose from. And then I choose from another 26 letters because I can repeat. And then here's a good question. How many digits are there? A digit is like the number 5, the number 6. There's 10 because 0 through 9. 10 is not a digit. 10 is made up of 2 digits, 1 and 0. So there's actually 10 digits, 0 through 9. So this would be 10, 10, 10, 10. And then you just multiply that all together. This would be a fundamental counting principle where you have so many choices for each one.